Welcome students into today's video. As usual, I'm Mr. Mithi for presentation in mathematics. Right, remember by what we have been doing in the previous video that we have introduced ourselves into a topic that talks about the chord properties of a circle. Right, so what we discussed previously, in case again we have some who have just joined us, please, I encourage you still more go back and revisit the videos, the previous ones, and be able to connect with us. Right, go through the previous theorems that we have discussed, so that when we're going to introduce a new one today, we should be able to move together. Right, now without wasting our time, we are going to be introduced ourselves into another property of the chord, in addition to what we discussed that time, where we're looking at the chord that is drawn, like say chord AB, in relation to the center. We saw that if I go the straight line from the center to the chord, as far as this line is perpendicular to the chord, like O to D, this line OD is perpendicular to AB, we really saw that this line bisects the chord AB. To mean that, say, if OD is perpendicular to AB, line AD should be equal to line BD. AD is equal to BD. Right, now today, what is it that we're going to discuss? Right, it's the same issues about the chords. It's chords, and chords. Right, so today, what we're going to look at is a different theorem from what we had. This is about the bisector of one chord, how is it related to the other chord. Right, look at my chart. If we have two chords of a circle that are parallel, in this case, then the perpendicular bisector of one chord is also a perpendicular bisector of the other. Right, you'll be able to realize that, meaning to say, if you construct a circle like this one here using a pair of a compass, right, and you happen to have two chords which are parallel, like say for example, I'll have this one as a chord AX, and then I have another chord here which is described by NH. Right, make that these chords are perpendicular to each other, are parallel to each other, meaning to say AX is parallel to NH. What is referred here in this property or in this statement is that if we have like here a line from O, which is the center of the circle, goes to the chord like that, to chord AX, and this line happens to be perpendicular to that chord. We all know that this line here, OF, let's call that line as OF. This line is bisecting chord AX by the previous property. Right, line from the center perpendicular to the chord bisect the chord. And again, if we may now consider the other chord, which is NH, and you consider a line again from the center to that chord, and that line is also perpendicular to the chord, as it is here for AF is perpendicular to AX. Let us also have a line, or maybe talk of a Q perpendicular to the other chord, which is NH. Just now by this line here, in relation to this chord, by the previous property, we'll be able to deduce that this line NQ is the same as what? Line HQ. OQ bisects the chord NH. Now, if we can look at the summation of the length of the two lines, or say if we join the two lines together, it will be like line O to F is perpendicular to the chord and is a little distance from the center to that chord, and the line OQ is also a perpendicular line, which is a perpendicular bisector to NH, then we'll be able to deduce that this line OF and OQ can be joined to form one line, which is defined as line FQ. Right, OF and OQ will be joined to form a single line, which is a straight line, which is QF. Right, so now if we can look at the nature of line QF, you see that this QF, on one end here, it is bisecting this chord AX at F. And the same line FQ is also bisecting this line here, that is NH. Right. So in this case, we are able now to deduce that, say, if we have got a line that is connecting, that's say, two midpoints of a chord, like here at F and Q, for the chords which are parallel to each other, we really have to expect that this is just like a common line which is bisecting what the two chords as such. So this is always true each time we have got the chords which are parallel. But where we don't have parallel chords, this does not exist. So now what I want you to do is you take your protractor and of a ruler and a pair of compass. Try to observe the reality of what we're discussing here. That says it's really true that this line will be a straight line, and at the end you find that itself is bisecting one chord on the other, and again the other chord in this other end. So what do? Just try to draw a circle using a pair of a compass, like what I've done here, and then draw two lines like AX and the NH. Make sure that the two lines are parallel, and then try to draw a perpendicular line from O to that is A from O to F. That is, this perpendicular line now is to AX, and another perpendicular line that is OQ to what? To NH. Then you'll be able to realize that this is just a single line. You'll be able again to see that, say, the line is just like one line in this case that is bisecting the what? The two chords as such. So what is referred here when we say two chords of the circle are parallel, then the perpendicular bisector of one chord is also perpendicular bisector of the other. In this case, we are referring to this line here, that is FQ. This is just like a common bisector. It's just like a single line. You find that this line here on its own is bisecting this chord, okay? And the same line is also bisecting this chord. So it is really true that, say, this is just like a common perpendicular line that is bisecting the two chords as such. So this is another property of a chord, that every time you draw a circle and you have got two chords which are parallel to each other, you should expect that the two chords will have a common perpendicular bisector. We're talking of a perpendicular bisector in this case. Right, so the perpendicular bisector here is referred to FQ. This line is perpendicular to AX at F, and the same line is perpendicular to NH at Q, because this is the line that is coming from the connection of two lines which are coming from the center. One line is OF, another line is OQ, which happen to be perpendicular to either sides of those two chords. Right, so that idea, let us have it always. Each time again, we are exposed to problems which are related to the circle and which are defined by the chords as such, in addition to the first one that we have. Right, now without wasting our time, can we now have some kind of problems which are related and they need some kind of application of such type of what? Properties. Right, so here with me, I have got an example where we have got two chords which are parallel. Example is laid like this. Two parallel chords are of length 12 centimeters and 16 centimeters. We are told that, say, if the chords are 14 centimeters apart, we are then asked to find the radius of a circle and then the diameter of the circle. Right, two parallel chords of length 12 and 16 are found to be 14 centimeters apart. What is the radius of this circle? And then let us also work out the diameter. You know what? the moment you find the radius, I don't think you can face problems to work out the diameter. Right, so that's it. So here, based on the property that we have here, it means we're going to generate that idea to say the 14 centimeters we have here, definitely that should be a common perpendicular bisector. That is just bisecting the two chords, which is 12 centimeters and 16 centimeters by the first property we have it here. So now that one is bisecting the two chords, which direction are we going to take in order to work out the value of the radius and the what? Diameter. So as usual, as I said previously in the previous videos, you'll be able to catch my statements which always say, when we are dealing with problems in geometry that are in words, we first of all have at least to have a sketch diagram with which we are going to refer every explanation that we have. So like here in this case, what I'll do, I'll draw the diagram representing the information of the question, like this. We talk of the chords, it means definitely the first thing I'll do, I will need to come up with a circle, because you cannot have the chords without a circle. So let me draw it something like this. Right? Look at this. This is my circle, right? Center O. This one is my center, and one chord is 12. So this one is 12 centimeters. I'll call this one chord AM. Another one is longer, so it means this one should be drawn at least closer to the circle for it to be longer. Though it's a sketch, but they have to be realistic. So this line will go like this, like that. Right, so this one is defined as the, let me have it here, T, B. Right. So that's what we have here. Right, so we are told that this one, from here up that is 12. And from here up that, let's regard it as what? 16. This is 12. Right. So they say the chords are 14 centimeters apart. So what I will do here, in relation to the property which we have just discussed, I'll consider a line coming from 2 points of these chords to be regarded as a common line that is there for both chords. Right. Like say for example, if I first of all consider only line AM, the distance from the center will be regarded by the line that starts from the center here. It goes to the chord like this, and that should be a perpendicular line like that. This line is described as O. Let us have this one outline because we already know this is 12. Let us have this line as line O, maybe P, like that. And the distance from O to this line TB, let it be regarded as this line O. Let's talk of what? D, like that. So that at the end, I should have a common line that is there between the two chords. So this line now is just the combination of OD and OP. So it means the 14 centimeters that is referred here as the distance between the two chords is just a line DP. So if we talk of the 14 centimeters is DP, a combination of the perpendicular distances from the center of the two chords. So OP and OD forms PD. So the PD is the one that is giving us a distance between the two chords. One is 12, another one is 16, like that. So we consider the distance from here up that is 14. Well, from here up that is what? 12. And from here up that is 16. Right, so what are we going to work upon? We are going to work out the value of the radius. That's the variable. So here, you need also to at least show which line is regarded as a radius. So remember again, as you'll be drawing the line representing the radius, draw in such a way that that of the shape should be something that can help you to do the calculations mathematically. So as such, I will draw my line radius to be represented by this line here from M going to, that is what? From M to O. So this is my line referred to as a radius. Right. So what I want to do here, I'll just find the value of the variable R, or let's just talk of the distance or M, which is the radius of the circle. Now to work out the value of the diameter, let's explain everything so that when we start solving, we should know the direction. Right. So the moment I find the value of R, we know for sure that diameter is made up of 2 radii. So it means what we do here, the value of the radius should just be multiplied by 2. This will give us the value of what? The diameter. So what is more important here is just to calculate the value of the radius. Right, so want to find it, multiply by 2, you have the diameter. Right, so now it's just like, how are we going to find the value of the radius? Right, so now if you can look here, sometimes mathematics, you can solve the value of the variable directly, but at times it's not always easy. So you do at least have to apply some kind of mathematical concepts in order to reach your value. Right, like 6 case to find the value of R. What does it do? You can find yourself taking different types of steps. So now let's see here with what we're given in the question and where we are going. So here you can see that we're given that the distance from here up to that is 12. So definitely we know for sure by the first property that the distance from the center to the chord, as far as that line is perpendicular to the chord, that bisects the chord, we expect that say AP is equal to what? PM, because we have got OP bisecting AM as such. So here we go and have our AP being equal to PM, which is equal to half AM, right? Why? You talk of OP is perpendicular to what? AM, right? So the answer we have here, it'll be just like half times 12, and we get what? 6 aside. So it means from here up to that is 6, and from here up to that is 6, right? So remember, we're working for other variables before we target our what? Our variable of our interest as part of the question. Maybe these variables we're finding can help us into finding the value of, like in this case, is R. So first of all, we have to work up the distance from here up to that and from here up to that. But specifically, what we want is the distance from here up to that, which is coming only when we apply the concepts that relate with what? To AM. So let's take the distance from here up to that, the same as from here up to that. It's because OP bisects AM. Now, let us also go to this other side of the chord. We are having OD perpendicular to TB. But the distance TB is 16. Therefore, we expect again, similar as what has happened here, that the distance from TD should also be the same as BM. Reason, OD is perpendicular to what? TB. Right. As such, it must bisect TB. So I'll write that one down again. Like this, we have our TD is equal to DB, which is just like half TB, like that. Reason, I'll write it here because of space. We'll talk of line that say OD is perpendicular to what? TB as such. Right, so look at that. Now, what follows then? It means TD, which is equal to TB, this one should be half times 16, and the answer we get is 8. Right, so it means the distance from here up to that is 8, and from here up to that is 8. Right, but now the distance from here up to here is 14. So let me just write my O somewhere here, and from here up that here we are given as 14. Right. Now, if we were there, sometimes to use the knowledge of Pythagoras theorem, we would have said, if we want to find the value of R, in this case, which is R, it's just a matter of just getting to know about the distance from here up to that in this triangle. Once we have here as 6, you can see that triangle PMO is a right angle triangle. And then issues about Pythagoras theorem can be what? Can be applied. But now here, we don't know the value of PO. Had it been we know the value of PO, we would have just used Pythagoras to say this squared plus that squared give us the what? The R squared. So we don't have the value of this side here, which is PO. So what we do, let us try maybe to find the value of this side. If it is possible, we find it, then we complete the issues about what? Pythagoras. So it'd be like, now, how can I find the distance from here up to that? Right. So don't make these mistakes of say that the distance from here up to here is the same as from here up to that. Some students are fast. What do? you just divide the 14 by 2, considering that PO is equal to 7 and here up to that is 7. No. Unless chord AM is equal to chord TB. The two chords will be on equal distance from the center of the circle. But now we are not told that this chord is equal to that chord. So don't assume that the distance from P to O is the same as distance from O to D. Right. So as such, we are going to use other mathematical application in order to find the two distances. Right. So what we do is this. If you don't know the value of one length, it's as good sometimes to represent it by a certain variable. So you work out the value of that variable, then you'll be able to introduce number of that variable and indicate it here. Right. So what we have here is just like, I don't know how long is it from here up this and from here up that. But from here up this is what? 14. So what I would do, I would say let PO be any variable, say X. Right. So I would say let PO be equal to X centimeters. So if PO is X, then what we expect is that OD should be the difference between 14 and that X. From here up to that is 14. From here up to that we say is X. Therefore, from here up to here should be that is OD should be equal to 14 minus X centimeters. That's what we have. So it means this one has been split up into two parts. This is X. This is 14 minus X as such. Right. So now we have got these distances here. But still more. If this is X, this is R. This is 6. This is the radius. The R represents the radius, which is just OM, our target. But now we can't use the variable and the number to find the value of one distance here. That doesn't make sense at all. How do you find the value of R? If this is the variable X, they have got one number. Yet we know using Pythagoras, we should have two values on the side of the triangle. Right. So what we do here, we are going to first of all do some kind of applications in mathematics that will lead us into the value of what? R itself. And that can also help us to find the value of what? X, that's the distance we have here. Right. So now, where are we going? To find the value of R, in this case, we need then to construct another radius over a circle. Like here, we have this one as the radius, which is R. We can also try to join O to B like this. Right. It will reach at that point. So if this is R, then this one should also be what? R as such. Because the radii what? Are the same. We know OB is equal to OM. They're both radii. So now what we have here are just like two triangles. Triangle OPM and triangle ODB. So let us try to use these two triangles by Pythagoras theorem in an attempt to find the value of R and formulate two equations that are going to be solved in relative way and in an attempt to find the value of X. Right. So here we go. Having this one as R, that is R. This is X. This is X 14 minus X. We have this in triangles talk over OPM and ODB. The two triangles are right angled. What we have here, it be something like this. Let me remove this chart here to create a space. You'd realize that in this triangle here, OPM, for us to find the R, you have by Pythagoras here, Pythagoras theorem, we'll have our R squared, this is hypotenuse side, will be equal to X squared here, X squared in that triangle, plus 6 squared like that. Again, if we come into this other triangle now, similarly, the same R, if it is squared, is also hypotenuse side, because this side is opposite to that. You have your R squared is equal to this side squared, which is 14 minus X squared plus this side, which is 8 what? Squared like that. So it's just like this is our first equation, this is our second equation. Right, the two equations are defining the square of r from this discussion here. Now, if we say r squared is this and r squared is this, what do you expect about this expression and that expression? They must be equal. So what we have here, we expect that, say, therefore x squared plus this one, we know it gives us 36. So you have got this one at 36 equal to that is 14 minus x squared plus what? 64. This expression should be equal to that expression because they're all defined by r what squared. Now, here, what are we going to do? Our target here is now to find the value of x as such. So, what you do here, you need just have to solve this equation here out and be able to find the value of x. The x you find, you are going to substitute here. And at the end, you use the value of x for this one and that one, or else in this triangle, 14 minus the value of x and 80, you'll be able to find the value of what? R as such. Right. So, to move quickly here, what we have here, that's x squared plus 36 here is equal to, if we're going to expand this one, because of time, we can just move as quickly. I've already done that one out for you. What we get for that, we'll just get something like, that is 196, right? That's a minus 20, that is 28x, right? Minus 28x, then 28x plus that is what? 64. For this part here, we get this one first of all. We square this one, we get 196. That is minus 28x. That is plus 64 plus x squared as such. That's what you have from that. Now, if you get that one out, what do we have at the end? Right. We have just like lines that like terms together, like talk of this x and that one, they're going to go, and here you have got 196 will be added with this one, you get some values there, and at the very end, what we have is just like an expression, which from this, it will give you that is 28 x, because this will come to this side, 28x, giving us equal to 224. Just to cut the story short, I think you can take the mathematics down here. It's not difficult here. What you do, you just have to expand this one. This bracket by multiply by itself. Then you add 64, you get this one here. So this expression related to this one, you just put the like terms together. At the end, you get this one here. Just to move fast, because I know students can calculate this. So when you divide both sides by 28, here again 28, the value of x you get here, it will be equal to 8 as such. Right. So that's what we're going to do here. Relate two equations as such. So now, if we found that x is 8, what happened then? Then here you can just substitute and write the value of x here, 8. You can choose any one of those triangles as such. So what you have here, finally, on the end point, what you have is this. Therefore, if this is 8, then finally, sometimes you can just get one equation here. Take equation 1 here. You say from 1, where we have what? R squared is equal to x squared plus that is 36. For 6 squared here is just 36. So what we do is just a matter of taking the value of x, which is 8, and substitute it here, which would be like x 80 squared plus 36. This gives you 64 plus 36, and the answer will have here is 100. Right, so you can see how we do here. And then once we have got r squared as 100, then you can be in the position to find the value of r by taking the square root of 100, which gives us positive or negative 10. So positive or negative 10. But here we consider a 10, because what we have here is about length. So we leave the negative value. Right. So here r is 10. So we conclude as to say, therefore, 1 radius is equal to 10 centimeters. What about 2 now? Diameter, from what I explained earlier, diameter should be twice the radius. So here you just have your diameter coming in from 2 times a 10, which gives you 20 centimeters. Right, so that's it about it. So some questions are lengthy, they are not all that direct. So expect such type of circumstances, and I'm happy if we are involved ourselves in such type of questions. I like what the question which always goes direct. Right, so please let us go through this question now and again in the video and try to understand the knowledge which has been applied in order to work out the value of the what? Of the radius and the what? The diameter, using the property which we have just discussed. Right, so with this, can end here in the video. What I'll do here, I'll just ask you as an assignment, just go through the same problem. In the other videos, I'll give you the exercise flight. With this, thank you very much for being together.